Here I have two propositional formulae. The first one says P and Q implies R. The second one says P implies Q implies R. So if I call these formulae A and B, we could try to interpret these formulae. So one example could be the formula A says, if I'm tired and I have coffee, then I will drink it. Formula B says, if I'm tired, then if I have coffee, I will drink it. It makes some intuitive sense that these two formulae mean the same thing. And what I want to do is test whether these two formulae are logically equivalent, and I'm going to use a truth table to do that. To set up a truth table, first I need to work out what my variables are. In this case, I have a variable called P, a variable called Q, and a variable called R. So I'll have these three columns. And I should also work out how many rows my truth table needs. Because I have three variables here, there are two things that P can be, true or false. There's two things that Q can be, and there are two things that R can be, and each of those is an independent choice, so I have 2 times 2 times 2, giving me 8 rows in total. Half of those rows P will be true, so half of 8 is 4. And the other half is 4 falses. For the top 4 rows where P is true, half of the time Q will be true, and the other half Q will be false. Same for the bottom 4 rows, half true, half false. Then finally for my R column, in the top 2 rows where P and Q are both true, half of the time R will be true too, the other half R will be false. And then all the way down here, each of these pairs of rows I'm going to have a true and a false for R. Now I need to work out the truth tables for these two propositions. I'm going to put these into the same table just for convenience so that I don't have to draw out the variables twice. Proposition A says P and Q implies R, so let's work out P and Q, and then let's work out P and Q implies R. This is my result for proposition A. The column P and Q, let's work this out in each of the 8 rows. In row number 1, I have true and true is true. In row number 2, I have true and true is true. In the remaining 6 rows, one of P or Q is false, so they have to both be true for and to be true. In the next 6 rows, true and false is false, false and true is false, and false is also false. So I have 6 falses. To work out column A, I need to do column 1 implies R. So I'm looking at column 1 implies R. First row is true implies true, which is true. The next row is true implies false, which is false. So notice that even though column 1 is to the right of R, I have to do 1 implies R rather than the other way around. True implies false is false in this case. The next row I have false implies true, which is true, and in fact false implies false is also true. Whatever I have in the R column, false is going to imply that. False implies true and false implies false are both true. So for the remaining columns, these are going to be true. For proposition B, I need to do 2 steps. I need to do the Q implies R, and then I need to do P implies that. So if I call this column 2, then I need P implies column 2, which is P implies Q implies R. And that's proposition B. For column 2, I need to do Q implies R, so I'm looking at the 2 columns for my variables Q and R. The first row I have true implies true, which is true. The next row I have true implies false, which is false. Row number 3, I have false implies true, which is true. In row 4, I have false implies false, which is also true. Rows 5 to 8, true implies true is true. True implies false is false. False implies true is true. and false implies false is also true. Finally, column B, I need to do P implies the result of column 2. So I'm looking at my column for the variable P and my column number 2. In row 1, this is true implies true, which is true. Row 2, true implies false is false. In row 3, true implies true is true. In row 4, true implies true is also true. And then in rows 5 to 8, I have false for P, and we know that false implies true is true, false implies false is true, so it actually doesn't matter what I have in column number 2, these 4 are all going to be true. And what does this tell me as a result? I can see that my column A and column B have the same values in each row. These are my two final columns for my formulae A and B, and they have the same truth values in every row. That means that whatever truth values these three propositional variables P, Q, and R have, my proposition A and my proposition B always have the same truth value. They're either true in the same situations or false in the same situations. That means that these are logically equivalent. So the way I would write this is to say that P and Q implies R is logically equivalent to P implies Q implies R.